Hi everyone and welcome to BGP Grid's video tutorial on dynamic default routing. In this example we have data center 1, data center 2. We're going to have the HQ, which is our primary location in data center 1, and our DR site, our disaster recovery site, in data center 2. This example is supposed to simulate these locations having a Metro Ethernet circuit and a layer 3 VPN over MPLS to a provider, which we're going to run the BGP over. Now, in real life, what you would have in this kind of situation is typically if you have the HQ, the DR, and you have a lot of different branches. In this example, we're only going to show a single branch, but you could do the same thing for as many branches as required. So right here you can see we have the HQ and DR. They're connected up to the ISP. In this example, I just have a simple static default route pointing up to the ISP. But we're really not going to even use that link. It's just there for visual purposes. And then what we have here, the outer links that you can see here, are going to run EIGRP. So this outer link here, this outer link here, and this inter-switch link here are going to run EIGRP. Typically with Metro Ethernet, you really don't have two circuits going to the branch. You just have a single circuit connected to the provider. But in this case, I'm doing it like this to show you the different options. The same thing with the layer 3 VPN. You would really just have a single circuit connecting to the provider on the branch, and that would pretty much be all. Now let's get started. I pre-configured EIGRP and BGP between HQ, DR, and the branch site. If you're not familiar with how to do that, you can check out our tutorials on our CCNA video. But in the meantime, let's get started. Here we have the requirements from the client. The first one is to receive a default route from HQ over EIGRP. Second is to receive a default route from HQ over BGP. Third is just a floating static route pointing to the DR site. And the fourth is sending a conditional default to the DR over BGP if the HQ site fails completely. So let's get started. I'll show you the config I have on HQ right now for EIGRP. So let's start with the interface. It's going to be Ethernet 02. You can see I just have the IP configured. If I want to look at the EIG configuration here, I'm just advertising the 172.16 network to establish the adjacencies, and I'm redistributing my static default route that I have configured, as you can see here, which is pointing to the ISP. So if you look at the branch, you can see in the routing table, it's learning a default route over EIGRP from HQ. Ethernet 02 is pointing up to HQ right here. And it's an external, so it's got an admin distance of 170. In this example, I have a BGP configured with the same ASN here. So it's a really running iBGP, which is why the distance is 200. You could actually, in real life, what you would do with a layer 3 VPN when you're running it to the provider would be eBGP. You would have all your different sites and different ASNs. They're most likely going to be private ASNs. And the admin distance here would be 20, not 200. In that case, the BGP routes are going to be preferred first. In this requirement, you want the EIGRP route to be preferred first. So what you would do in that scenario is to change the distance for internal and external EIGRP routes under the router EIGRP process to be less than 20. So, but that's a different tutorial that we're going to do later on. In this case, we'll just focus on what we have here. So right now, the EIGRP default is being preferred to HQ, and that takes care of requirement number 1. Requirement number 2, you want to have a default route on the branch pointing to HQ over BGP. So let's go back into HQ. Let's get this done. The BGP configuration on HQ looks like this. Because it's iBGP, we have the next hop self specified along with allow ASN. in. If you're not sure what that is, shoot us an email and we'll be happy to answer it. Or you could do your own research online. Let's see. So let's originate a default over BGP to the branch. Go into the BGP process, neighbor 192.168. Well, let's actually start with the network command. And neighbor 192.168.1.6 default originate. And when you go back to the branch, you should see it in the BGP rib, and here we go. And as you can see, it's a rib failure, noted by the R here, because the default is coming in from EIGRP with a better admin distance. You could also take a look at show IP BGP rib failure, and it'll give you what the reason is. The rib failure is because it has a higher admin distance. Alright, so that takes care of requirement number 2. But first, let's test shutting down the link to HQ over EIGRP. So let's go to HQ, let's go to Ethernet 02, and let's shut that link. Now what we should see on the branch is the default over BGP get installed. It'll take a couple seconds for EIGRP to go down and withdraw the route. And there you go. The BGP default has now been installed. So now we know that it works perfectly fine. Let's turn that link back up. And the EIGRP default should come back. And it does, as you can see here. Perfect. Okay, let's go to requirement number 3, a floating static route pointing to the DR. So this is if the EIGRP and the BGP from HQ fail. We're going to have a floating static route which will take precedence and point to the DR. So let's configure that on the branch. IP route 0 to 0 to 0 to 0, and same thing. And the DR link Ethernet 01 is .172.16.1.9. And here, in order to set the floating static, we'll change the admin distance to something higher than both so it doesn't get installed. So it has to be higher than 170, it has to be higher than 200 in this case. Let's just make it 210. If we look at the routing table again, make sure it doesn't get installed, and it doesn't. You still see the default from EIGRP being learned. Let's shut down these links from HQ to see if the floating static does get installed. So Ethernet 01 and 2. Let's take a look at the routing table again. It'll take a few seconds. You can see the EIGRP route got withdrawn. We're waiting for the BGP route to get withdrawn. So once the hold time expires, it should withdraw the route. I'm just going to go ahead and clear the BGP process to speed things up. And okay, perfect. Now we can see the floating static has been installed and it's pointing to the DR site. So now let's go ahead and let me just turn those links back on HQ, because now we know it works as expected. And then we'll see the EIGRP default take precedence again on the branch. So let's check the routing table now. And yep, as expected, the default from EIGRP now comes back and it's pointing to HQ. Alright, let's just save these configs real quick. Now the last requirement is to send a conditional default to the DR via BGP. So in this case, what we're going to do is, if the branch, does not see, if the DR does not see certain routes being received from HQ, it's going to inject the default route to the branch. And this is done with, by using the advertise map and non-exist map commands in BGP. So if we look at the BGP table here, we can see what we're going to check for is the loopback of HQ, which in this case is 1.1.1.1. Here you can see it's 1.1.1.0/24. So let's go ahead and create a prefix list to match that loopback address. And we'll call it check HQ /24. And what we'll do is we will create the advertise map portion and we'll call it send default. And we'll match the default route. Now let's go into the BGP process and advertise the default, but the magic happens here when we tie that to the neighbors. So it's going to be 192.168 1.10 advertise map send default non-exist check HQ. So if the loopback, like I said, does not exist, it's going to advertise the default to the branch. Okay, so let's see if this works. Let me just check the branch, see if I am receiving the default from the DR. Which I am, which is right here. It's obviously going to be a RIP failure, and as you can see, the best path is going to be to HQ. So let's do this. Let's shut down the links from HQ, and we'll see if the DR will advertise the default route. We'll also get rid of the floating static route. So I've gone ahead and shut the links on HQ to test this, and what I'm seeing is that the BGP default is still coming in via BGP, even though the loopback is still seen at the DR. We don't want that to happen. What we want to happen is if HQ completely goes down, we want then the default to be advertised via the DR. So what I just realized is when I configured the advertise map and the non-exist map, those are referring to route maps, not prefix lists. So let's go ahead and create the route map for this, and we'll call it what we have here. So send default, we'll name it the same thing, permit 5, and here we'll match the prefix list. Also called send default, match IP address. And we'll do the same thing, create the route map for check HQ, permit 5, and we'll match on the same prefix list. Oops. Check HQ. Now the route maps actually exist and they should take effect. Let me clear the BGP sessions. one more time. So the HQ sessions are still down. I'm only working with the DR right now. And as you can see, we're not receiving the default on the branch anymore. Let's check the routing table, and it still has the static route. Perfect, because if we look on the DR, you'll see the loopback is still there from HQ. Let's wait a little bit though and just double check that the default is not being received. Still have the static route. Okay, so what we're going to do now as a final check is we're going to shut down the link between the DR and the HQ so that this loopback IP, that subnet, goes away. And then the DR should inject the default to the branch. So let's shut down all these links to the DR. Now this is assuming a complete failure at HQ. I've shut down these two links and I've shut down these two links. So we should see the loopback subnet get withdrawn. It'll just take a little while. So what I'm going to do is I'm going to clear the BGP process to speed things up. You really don't want to do that in real life. I'm just doing it in this lab. It's a lot quicker, so we don't have to wait. Let me take a look at the branch. Give it a minute, because I cleared all sessions. I should have just cleared the session to the HQ. And finally, the BGP table updated on the branch. And as you can see, we are receiving a default now pointing to the DR. Let's check the routing table. And it does get injected. So that's how you do a conditional default advertisement via BGP. It looks like everything is working as expected. Let's go ahead and re-enable all these links. And we should see the EIGRP default going back to HQ come back up. Let's take a look at the branch. And here we go. As expected, the EIGRP external route default pointing to HQ is now learned over the 02 circuit, and we're all good. If you have any questions, feel free to shoot us an email. Otherwise, we'll see you in the next tutorial.